test intelligence analyses and how test intelligence can help you find more bugs in less time. And we want to demo our tool TeamScale that implements these analyses. And this session will have 2 parts. In the first part, I will lay the groundwork to give you an idea of which data these analyses work on and how it looks like. And then the second part will be the live demo to give you a good feeling how the tool feels itself. Before I start, please don't wait with questions until the end of the session. Instead, interrupt us directly. And it needs not be a well-articulated question. It's fine if it's skepticism or doubt or opinions. We are a size in which it's easy to discuss things. So if you want, make it as interactive as you like. And it would be great if there's online questions, if somebody, if you could read that to me. Perfect. So the key idea of test intelligence analyses is to analyze the data in the repos that collect data during engineering and testing. So the version history, the tickets, the test coverage, and so on, to help us focus our testing efforts on those areas that are most likely to contain bugs, or to tell us where we have tested a lot already and which tests we maybe don't need right now and can focus the effort in other areas. And to give you some background on us as a company and where the experiences and the tool comes from, just some background. We are a spin-off from the Technical University in Munich. I'm one of the founders. We are today 62 employees, 58 of who have a master in informatics or computer science, and 23 of us hold a PhD in software program analysis. So we're very focused on that topic. We have some colleagues in California, because that's where some of our biggest customers are, and the rest is mostly in Germany, because that's where we come from. Last slide on background, that's some of the companies we work for. And obviously software looks different if it's written in C and runs in a car in an ECU, or if it's an insurance system written in C#, or if it's a COBOL software that runs on a mainframe. But if we take a step back, this challenge that we want to test more and more functionality because successful software grows, and less time because release cycles are getting shorter. This challenge we see across the different domains and programming languages in organizations. So what we present today is not limited to single domain or organization or process model. And the key idea behind test intelligence analyses is to give you transparency into the black box of software testing. And I like to explain that using a metaphor. For those of you who've been in my talk before, this is a short repetition, but afterwards you will see new stuff in the demo. So I think all of you know X-rays. This is my kneecap, my right kneecap. And this picture was taken 2 weeks after the surgery, where the surgeon put the pieces of my kneecap back together. And I have it here because this was a very effective Q&A session that the doctor did with me. And this doctor, he did not retest all. He did not take a blood sample. He did not measure my temperature. He didn't even ask me where the pain was. Instead, he only took this picture and then looked at it to see if the result matched the expectation he had. If the change the surgeon did to my system had a result he was expecting. So this is the key idea for this talk. We want to get transparency into the black box of software testing. Or to phrase it differently, we want to enable you to be more effective and more efficient. More effective means we want to find more bugs in the same time, and more efficient means we want to be able to find the same bugs in less time. And what do I mean by this? Let me show you using a visualization called a tree map. This is our own code base. Every rectangle is a component. The bigger the rectangle, the larger the component in lines of code. And now we step in. This is the files, and this is the next slide is the methods of our code base. Roughly 50,000 methods that together form our program analysis tool. And since we do program analysis, for example, of Java programs and 34 other programming languages, whenever a programming language gets a new version, for example, with a new keyword, we have to adapt our code base to now be able to understand the new version. And when Java received closures as a keyword, this is what changed. Gray means the code area that was not changed. Yellow, orange is modified code, and red is new code. And you see the change is spread all over the code base because it affects the lexer that turns the program into tokens. It affects the parser that turns the tokens into a syntax tree, and so on. So, and now if we test this, there's basically two questions we have. The first one is, can we now understand Java? And we need new tests for that. And the second question is, does all the old stuff still work? And to answer that, I now want to run our test suite in a time lapse. So if I start that, we run 30 tests per second. All the methods that are executed by one test flash white and then fade to green. So we see how the test coverage builds up in our test suite. And you see that in some areas there's a lot of different tests, other areas are tested more sporadically. But you see that there's a whole lot of information in this test suite that we can use for these analyses. So to produce this animation, we measured the coverage of every single test case, and we computed the changes performed to the ticket, and we can use all that information now to optimize our testing efforts. And I stop the animation now, because the key point I want to make is when we tested something, it turns green. But here you see that most of the changes are still orange and red. So the tests we ran did not go through those changes. But if a test does not execute modified code, it cannot find a new bug in that modified code. And back then, when we implemented this, we had roughly 5,000 automated tests. And of those 5,000 automated tests, only 4 traversed the modified code. Not 4,000 of 5,000, but 4 of 5,000. But all the 4,996 tests that don't execute any of the changes, they cannot find a new bug, so that they are superfluous right now. Yes? Good question. Let me repeat this. Am I speaking of unit tests or integration or end-to-end tests? In this case, all of that. So there were unit tests in there and also integration and end-to-end tests. But for the animation, I only had unit tests. But back then, we also had integration and end-to-end tests, and it still holds that only 4 ran through that. And that should actually not surprise us, because when we wrote those 5,000 tests, we didn't write any tests for Java closures, because we didn't know those closures would come up. So from a efficiency perspective, this is very wasteful, because almost all the tests we executed couldn't find a new bug. But from an optimization perspective, that's great news, because there's a lot of potential for optimization, and that's what we do here. So an analysis called test impact analysis looks at all the tests. It looks at the changes that were performed since the last test execution, and then it throws out all the test cases that we know won't run through modified code. And if we now executed all those tests, probably some would pass and some would fail. And it could be that after this filtering step, there's still a lot of tests left. So in a second step, we reorder them. And in an ideal world, we would order them like this and put all the failing test cases first, because with the first failure, we could stop the pipeline and don't need any further tests, because we know we have to repair something. Obviously, we can't predict which tests will fail with 100% accuracy. If it's undecidable, then we wouldn't need the test in the first place. So there's a lot of research that reorders those test cases in a way that there's a high likelihood that the test failures are first. And we've tried with a lot of different heuristics, and we've come up with one that always executes that test case next, that per second of test execution covers the most modified, untested lines of code. That was a mouthful, but it's implemented in the tool, and it runs in the background. And if you integrate that into the CI, it always runs those tests next that have the highest likelihood of quickly finding new bugs. So that's the first analysis. And how we integrate that is that you execute all your tests with one time to measure the test case specific code coverage, so we know where the tests will run through. And then whenever tests are executed, for example, during the continuous integration pipeline. We extract the code changes from version history, select the tests, prioritize them, and then have the list of impacted tests that are most likely to find new bugs. And from our empirical research, we've seen that on average, across many systems, in 1% of the time it takes to execute the entire test suite, we on average find 80% of the bugs that the entire test suite finds. And in 2% of the time it takes to execute the entire test suite, we on average find 90% of the bugs that the entire test suite can find. To find the rest, the remaining 10%, we need the remaining 98% of the time. So this works well if you very frequently run the small impacted set of tests, and every now and then run the entire suite to catch the bugs that slip through the cracks. So this is efficiency. We can find most of the bugs in a very small amount of the time, or with a small amount of effort. But all of this cannot help us if we miss the test cases. If we don't have the test cases, we can, yes? Just a second.
How you integrate the selection of the tests in the pipeline? Is it because the tool makes kind of a prediction which one are the ones which would fail first or fast, but then you have to change the order. So the pipeline now receives the order of the test cases from the tool, or how does it work?
Yes. The short answer is yes. We produce an ordered list of impacted tests and feed that to your test execution tool, test management tool, so that it executes them in that order. Okay. Sometimes there are constraints on which tests can be reordered and which cannot be reordered. We can take those constraints into consideration so as to not create test failures only by executing them in an invalid order.
So that means the order of the test is always piped through the tool, and sometimes it's changed or it's adapted to what is tested.
Yes. For this analysis, we change the order of the tests because the default order is usually very inefficient. Because the default order is typically you have a cluster of tests and you run all the similar tests one after another. So the first one has a high likelihood of finding new bugs, and then all the other tests in that cluster have a lower likelihood of finding new bugs. And it's much more efficient to have a different order. Thanks for the question. So the second analysis I want to present is about effectiveness. Where can we find more bugs at the same time? And this targets those areas where we don't have enough test cases. And the basic idea is to use the same information, the changes from the version history, and the code coverage to show us where are untested changes. Because for long-lived software systems, untested changes are those areas that have the highest likelihood of introducing new bugs. And this is a screenshot from a system, a tree map from a system from Munich Re, the world's largest reinsurance company. They have allowed me to show this, they have allowed me to tell that it's from Munich Re, but they want me to tell that this is 10 years ago, and now it's obviously much better. So for the sake of completeness, I've done that now. And 1.5 million lines of C# code. Gray means not changed since the last release. We expect fewer bugs here because we tested this in previous releases, and if it was really broken, users would have probably told us. And all the colored stuff is the new and modified code, and only if it's green was it ever executed during testing. And how do we interpret this? The green stuff, we don't know if there's any bugs left. Could be that we found them, could be that there's still some in there. Just a second. And all the orange and red stuff is modified in new code, tens of thousands of lines of code here. And we cannot have found a single bug in there because we never executed this during testing. And this is already, you had a question before which types of tests, and this is coverage from automated unit tests, automated end-to-end tests, manual regression tests, and manual explorative testing. All of that already in there. And the key idea of this analysis is to offer us a conscious choice whether we want to ship like that or whether we want to do additional testing. And let me just finish those 2 slides, and then we can take some questions while Jakob builds up the demo. We use it ourselves for the development of our tool on the level of tickets, because often it's easier to prioritize tickets based on their risk than code, because code is further removed from business risk. And in our development, we cannot merge feature branches or close issues and tickets if there's still untested changes, if there's still larger test gaps in there. And this helps us be thorough and make a conscious choice whether we need some more testing or whether we've been sufficiently complete in our testing efforts. So I went quickly through 2 analyses. The first one selects tests based on changes to allow you to quickly find new bugs. And the second one reveals untested changes to discover areas where you need new tests, otherwise bugs might slip through cracks. This concludes the first part. Which questions do you have before we do the demo? There was one question.
Simple question about coverage.
Jakob?
The question about the coverage, is it line-based, is it decision-based, is it choosable? Because like green being executed, one line doesn't mean a lot.
Yeah, good question. It's choosable and it depends a bit on the target platform and how much performance impact you can tolerate in there. For some customers that already capture statement coverage or MCDC coverage, we have it on a very fine-grained level. For other, especially if it's very large systems, we often work on a method level because we are mostly interested in those big gaps. And there you have a very negligible performance impact if it's on a method level. Thanks for the question. Further questions?
Me again. Is there a view where I can see how the new tests perform? Because usually if you change something, you add as well new tests. And sometimes it's nice to see if the new tests test the right things.
Yeah. For the test selection, when there's a new test, we always automatically select it. And for the test gap analysis, you can take a look, if you execute new tests, how much coverage was added. Maybe we discuss that later.
Yeah.
Thanks.
Now, we do have a complicated tool with lots of modules, with different types of unit tests, BDD tests, integration tests, you name it. Different tags, different setups, different environments. How am I able to feed this configuration of different scenarios and filtering tests into your tool and still have the advantage of then being able to run only those tests that are relevant? Could you share a few minutes about how this is configured?
Let me give you the gist of it, and if you want more information, let's go deeper afterwards. But the key idea is we connect to the version control system and analyze all branches in all repos you have and build up a very big database of all that information. And then when you run tests, we tag the coverage information with a specific branch it was run on. So we can attach that to the specific branch, and then we can cross-annotate that to other branches. But we know what changed between those branches. Because what often happens is that you don't run all the tests on the same version. Maybe you run the unit test and then in the build on every version, but the manual acceptance test is maybe running at the same time on a version that's 3 days old. So we can't simply merge that coverage because it's from different versions. And we do that in a way that takes into consideration what changed in the code base in those 3 days on the different branches. And then you can select for which branch you care about, which coverage, and then compute all that information. That was a mouthful, so short version is we have taken that into consideration. I can give more details afterwards.
Thank you very much. My name is Jacob, and I'm trying to do all that in practice what Elmar just presented right now. So if I'm doing not too many things wrong, you will recognize things you have already seen on the slides. What we already told, that TeamScale is the tool that does the analysis today. What I tell you right now, that TeamScale is also our study object. So we need some demonstration object for today. It's also TeamScale. I will separate those two TeamScales later on so you will clearly see the difference. I at first brought you our testing pyramid, and as you can see, most of our tests are unit tests and they execute quite fast. We have some integration and some system tests, and we have also some unit tests, UI tests, that take roughly half an hour. So that's pretty long for our pipeline, but they find important bugs, so we need to run them nevertheless. But what we do to improve in our CI is to select the tests that target our changes. So exactly what Elmar presented earlier, we use test impact analysis to only run those tests who run over changes. And this towards that. And now we need a more specific demonstration object. And Elmar already told us that TeamScale is connected to the version control system. And for the version control system, we need some way to connect. We need some credentials. And therefore, you can just store external credentials, account credentials for your Git repository, for other things in TeamScale. As you can see, we have the possibility to edit them. We can set the permissions to edit the credentials, but what we missed to implement, that is our demonstration case, is the deletion feature, and we wanted to have it. So that's a made-up case, obviously. And we also have this stored in our Jira as a ticket, so it's a feature, and this is our study and demonstration object. What already happened is that this was implemented, and my job today is to see whether it's thoroughly tested or not. So what we have not done so far is to execute the CI that would normally run automatically and execute all the automated tests. Any questions to the setup so far? Okay, so I will leave PowerPoint and go to TeamScale first to show you how this information that I've just shown on the slides is stored in TeamScale. I first have to log in, and then we see on the left-hand side some different perspectives that offer different viewing angles on the data TeamScale calculates. And today we go to the test gaps issues perspective, where we recognize the same issue I've just talked about, enable deleting account credentials. We see some meta information that is important from the bug tracking or feature tracking system. We see that Elmar is assigned to implement that feature, and when I scroll down, I also see a commit in the version control system associated with that issue. If we know the commit, we can also see which files have been changed in course of that commit. And if I would look any closer into that file, I can also show which methods have been changed. So, and which methods have been changed, you know, this diagram or this tree map from before, from the slides, you see that a number of methods have been changed. Those are the orange ones, and a number of methods have been added here. And right now, everything is still yellow and red and not green. Let's change that. Normally, the CI would automatically run when we push the changes to our version control system. Today, I do that manually by on the command line. What happens right now is that the build is triggered, the compilation is running, and it really targets your question now. So what happens in the background is when now also the UI test server is starting, and we need to do some analysis and prerequisite to execute our UI tests. And then we go back to TeamScale, not we, but the CI tool, and asks TeamScale which test cases should I execute right now. And that is what you can see also here in that UI view. You can see that 4 test cases are suggested to be run right now. And how is that done? If I click on that test case, I open it up in a new tab, I see which methods have been executed. So again, all the gray ones are not executed and all the green ones are executed by this very specific test case. Knowing this, when I now change any methods that have been executed by that test case, and I know that I most likely want to execute that test case again, but not the other ones that do not execute any changed or added method. So what happens right now? The build is the UI test server was started and the UI tests run. And let's just, I don't want to move the mouse, maybe I will break it then. So you can also see that is our TeamScale under test, because it looked like a little bit different. It had a light sidebar on the left-hand side, and so the tests are already finished. Let's see on the command line what happened. So I have to make it a little bit bigger here. So what can we read here? It's a little bit technical, but we have executed 1, 2, 3, 4, 5 tests. That's one more as suggested. That is because what you said, I will add new tests whenever I added a new feature. And you can see there's a test executed that is named can delete external credentials that did not exist before. And that targets our new feature that Elmar has just implemented. And it's the only one who that fails. That's obviously not good. All the other ones, the 4 other ones, did pass. That's good. And what's also good is to look at this execution time. The build failed just after 1.5 minutes. As I said earlier when I showed our test pyramid, our UI tests normally, if I execute all of them, take half an hour to execute. And now after 1.5 minutes, I can go into the code and just check what is wrong here. And also those test results are published to TeamScale. So if I, for example, go back here into all the external credentials view tests, I can now see there's a test failure here in TeamScale. I can see there's some expected condition that failed. And also here I see which methods were executed. So what do we have to do if a test fails? I would give it back to the development team and hope they fix it soon. For today, I will not do any live coding, but I wish it would be always so easy. I just type apply fix and hopefully it magically all works. So what happened right now, we moved just one commit forward in the version control system. And then right now the CI is running again. So you see the same state as before. We are building or spinning up the UI test server, have to wait a minute until it's done. And yeah, we will run all the impacted tests again. If we now go to the issue view that I've shown earlier, where still one commit is shown, if I reload it now, I will see that there's one additional commit that says, we fixed that external credential removal now. And we can also see another effect that was triggered by our test execution from before. We see a lot of those methods are now shown in green. And one method is shown in orange, and that is the delete element method. The delete element method was the method that has been changed to apply the fix that it now works. And you might have seen that another UI test just started and finished in the meantime. And I again go back to the console here, and we can see right now we have executed just a single test case. Just a single test case, and it was just the can delete external credentials test. The build took roughly about 1 minute, and we can see we did not execute like 5 tests again as earlier, but we executed only the one test that tests whether the deletion now works or not. What does that have for an influence on this view? I will reload it once again, and you see the method that was earlier yellow because Elmar modified it a second time to fix the bug is now again green because it has been run in the test. That is very good. But there's still one red one, and I will cope with that red one soon. But you have a question.
Microphone? Microphone?
Okay, sorry. Just to clarify the difference between the colors. Yellow means there is a test and it's failing, and red means there's no test and at all.
Very good question. So the colors orange and red only mean compared to a starting date, so before the implementation of a ticket, whether the method existed before and is modified, that is orange, or whether the method is completely new, that is red. It's only to distinguish whether it's added or changed. Right. So it has nothing to do with whether a test exists or whether it fails or passes. So now I have here a tree map that has still one red method, and I can see this method, the tree map here in TeamScale is interactive. I can hover over it. I can see which method it is, and it is reject deletion if credentials are in use. So we use these credentials to connect, for example, to a Git repository or version control system. And whenever these credentials are in use, I want to get an additional warning. And that is something that also Elmar implemented in course of that ticket. And it seems that it was missed to write a test for that. I can now, based on this tree map, draw a conscious decision whether it's fine for me to just release as is or merge the ticket as is, whether I want to write an further automated test, or whether I want to do a manual test of this specific feature or part of the ticket. And I right now decide to do a manual test of this, and therefore I just spin up a testing instance of TeamScale where I try to delete a credential that is in use by a project, by a TeamScale project. And this is also, so this is not made up. You can just do it if you're a TeamScale developer. You can spin up this testing instance and push that information then to our productive TeamScale instance. So I go into the browser and open up the other instance of TeamScale, so our TeamScale under test. I log in. And now you see this is the other TeamScale instance, the TeamScale under test. And we can see there's one project, Earthwalker, and this Earthwalker project has some credentials, and it's pointing to a Git on the local file storage. So I just spin up another test credentials here. It's pointing to some folder in order to show you how it would look like if the credentials are in use by no project. I make it a little larger. By no project. Then I click on delete. I need to say I really want to delete it, and then it's gone. What happens if I try to delete credentials that are in use of a project? I click on delete, I delete it, and there's an additional confirmation needed in this case. That was exactly the test case that did not exist so far. I click on force deletion, I don't want to see that again, and now my test case is successful. I can delete credentials even if they are in use. That was the requirement, and therefore I can now just shut down the test server here. What happens in the background now is also of that manual test, the code coverage is pushed to our TeamScale that does the analysis, and we will also see that here in that view. So we see this, there is a manual coverage upload from just a minute ago. I can click on that, I can see which methods got executed during this manual test session, all of those. And if I now go back to the issue test gap view for this specific issue, I see that now the test gap that was here, reject deletion if credentials are in use, is completely covered by now. So I have a complete code coverage for this specific ticket. Any questions? Yeah, two.
For the manual testing, what was your assertion, or where did it come from? You just go to your TeamScale under test and clicked on somewhere, but what was the assertion?
Yeah, it was a little bit shortened here for purpose of the demonstration. So it was to look whether the deletion also works in case the credentials are in use by a project. But so you don't have to question this specific test case. What I wanted to show is that you can identify this test gap and then have a manual test that in reality should be better specified as what I have done right now.
You show something on the local host, and you stopped when you have done your manual test. How does this work in deployed version?
It works exactly the same. You can. So it depends on the test setup. So for example, if you have a test server somewhere that needs to run over and over again, you can just periodically push the coverage to TeamScale, or after each test you say the code coverage profiler should push the coverage to team scale. So there's no need to stop it, but I did it just for this demonstration here.
Any more?
Just to come back to the manual test case.
Yeah.
The system recognized that you called a method which was not tested, but if you're not satisfied with the outcome on the manual test system, because it's getting green because the method is called, but there's usually the other case that maybe the method is called and there's no technical issue, but you are from the business side not satisfied with the outcome. How you document this, how you interact with the system?
That is separated. So the test results are not, so you have the opportunity to view test results in TeamScale, but usually there's a test management tool where you store your test cases and you say, this test case failed because you're not satisfied by the outcome. So this is separate. So what TeamScale or the test gap analysis allows you to do is to see that there is still something untested where a bug potentially could be in. It just shows you that you haven't got to the point where you have tested all the changes yet.
And the second one, I have a lot of questions usually.
Yeah, that's fine.
It's own tool. It's not available like a plugin for other ticket systems where you just want to add these informations, because usually big companies have a tool at place, and to replace the tool completely is usually out of scope.
Yeah. So the calculations are done by a separate tool, but we have integration into several places like GitHub, GitLab, several bug trackers and whatever, to have the information present. But for example, it wouldn't be easily possible to come up with a plugin that does all the calculation, does all that visualization, and that is why it's a separate tool that does the analysis, but you have the results available in your usual development environment or test environment.
Let me just repeat that because it's so important. We don't require you to change any tooling. We always integrate into the tools that are already in place.
I think there was one question from the back of the room.
Hello. From my software engineer perspective, for me it's like you need to have like 100% coverage in your project to implement this tool and work properly like you have right now, because from what I see, there are a lot of projects that they don't have 100% coverage, and if I from my perspective, if I start seeing all red, I don't care. It's like, oh, today is red, tomorrow again, and they will be over and over going green. But for me, it's like, I don't know. Maybe is that's it. That's my question. If I need 100% coverage.
Excellent question. And very few times have we seen close to 100% coverage in practice in any project. So the typical projects we start with, especially if we start with test gap analysis, is they have a low coverage in automated tests, many of them, and do a lot of the testing manually. And then you can't really speak of a coverage, of a certain coverage number anyway, because you usually have different sets of manual tests for different releases. And the key contribution here is to allow you to focus your manual testing on those areas that are most bug prone, and give you better transparency what you manage to test and what not. And also to raise your hand and say, we've spent all the budget we had on manual testing and still half of it is not tested. You can't be mad at us that bugs will be shipped if you don't give us more budget for the next run of manual tests. And then often when the level of automation increases, teams also start with a second analysis where the test impact analysis tells you which tests to execute now. We have also some teams that use test impact analysis to select manual tests, but the typical place to start is test gap analysis.
From my question would be what kind of information TeamScale need in the report to do this analysis, or is every report possible to interpret it?
Coverage report, you mean, or?
Yeah, It depends. If you're taking this, for example, it was an UI test. So, and at the end, I get a report with steps, or it depends on the tool I use for the test automation, or what kind of report I need to do this analysis.
Also, very good question. So, towards the reports, we do not need to know which steps were executed. We need a technical code coverage profiler attached to the test environment, and that is available for most of the modern technologies. And from that, you get a report out which methods or lines of code have been executed during the test, and that is what then is pushed to TeamScale. So TeamScale does not know the content of the test.
Okay. Thank you.
The one in green.
Follow-up question to the scenario that you outlined about the manual testing. How do you know, or how do you store the information about what exact manual test has been performed that produced a certain coverage? Like, it's completely different if I press the button or if I press the drop-down box or whatever scenario it is. How do you record that? Because the output should then be, in order you have modified these, we suggest that you perform those manual tests again.
Good question. For test gap analysis, we don't need to. We don't need to capture test case specific coverage for manual tests because we want to see the gaps. If we want to be able to tell you which manual test to execute to run a certain functionality, for example, during a hotfix case, then we need you to click somewhere when you start a manual test and click again when you finish that manual test so that the profiler knows from which point in time until which point in time coverage belongs to that manual test case.
Do you have an integration with the test case management tool then? Like I have 100 test cases in test trail.
Yeah.
And I perform them manually. How do you know which test cases are performed, with which parameters are performed, what's the timeline of the test, and so on?
By connecting into that tool, or by having a separate UI where you select the test case and click now we start and now we end. Thanks for the question.
The examples which you showed, there were red and green before when it was red, there were no tests, right? So no unit test, no integration test.
We just assumed we stopped after development and paused, and then we run the CI, and that was the point when we got more green, because there were just no test cases run so far for that.
Okay, but I think that's not very realistic that you push some code without a quality gate, right? So there could be some red parts, but not entire component without any single test. Then there would be some blur or a bit green. But because my follow-up question is, red and green means only I have a test or I don't have a test. My follow-up question would be, let's say the tile or the rectangle is green. I have a unit test, but that doesn't test edge cases. Now I go to the UI, as you said, there are more realistic tests. You will find very fast some edge cases or some tests which still lead to null pointer exceptions or something like that. And there is still a unit test for that. It should be green on that graph. So how you deal with that? So even a green test could even have bugs, right?
Yeah. So two answers. The first one is, we never tell you to stop testing just because everything's green. And we keep telling that. I hope it helps. And the second part is, you can capture coverage specifically for different test types so that you can focus on a single one to see if the coverage there matches your expectations. We can, I think we're running out of time and only have 2 minutes left, so we can discuss that afterwards in more depth if you want.
I used the 2 minutes to show you what Elmar already told in his part, that there is some plateaus. If you, for example, use the normal test execution ordering, and with knowing like which test covers the most of your system in the least amount of time, you can change that to a curve looking like this. So this is very beneficial if you try to reduce testing times. I will use the remaining minute to just repeat what we have seen so far. So we have in our regular CI, that would take us 30 minutes until we would have all the UI tests executed, and then we would know, there's a bug. And with our test impact analysis applied, we knew after 3 minutes that there is a bug. We did a bug fix, and we did a retest, and after 15 minutes roughly we were finished, and also did a test of a test gap. And I will skip this. So whenever you have more questions, just go straight out of the room, and to the right there is our booth, and we are happy to answer all of your questions there. We have some material, additional material on our analyses. And yeah, I thank you for your attention, and it would be great if you rate this session. Thank you.
Thanks.